Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body, and Archimedes upthrust. This exercise was a previous one in the Breve exams in 2009 second session, third exercise. The title of this exercise is Determination of the Density of an Alcohol. In order to determine the density of an alcohol, we take a solid S suspended from the free end of spring balance and two containers, one containing water and the other alcohol. Take G is equal to 10 newtons per kilogram. So notice that till this moment they didn't mention anything about figures 1 and 2, then we are not allowed to use them. Number 1, real weight of S. So S is in equilibrium in air. The spring balance indicates 80 Newton. This indication represents the value of W of the real weight of S. Why? Because it is in equilibrium and in air. Then let's say since the suspended object is in air at equilibrium, then the spring balance indicate its real weight. So the real weight in this case, which is denoted by WR, is equal to the value which is 80 newtons. So here it is important, let me write that the real weight is given by 80 newtons. Now in the second part of this exercise, volume of S, we immerse S completely in water of density ρ is equal to 1000 kg per meter cube. So here the density of water is given by 1000 kg per meter cube. So they mentioned figure 1, now we can use only figure 1. Yet they didn't mention figure 2. So the spring balance then indicates 7 Newton. Now number 1, what does the indication of the spring balance represent? Knowing that the solid S also is supposed to be at equilibrium, but in this case it is in water and not in air. So the spring balance will indicate the apparent weight of the solid S in water. So let's say we are in part 2, number 1. Since the suspended object is immersed in water, immersed in liquid, and the liquid in this case is given by water at equilibrium, then the spring balance indicates its apparent weight. Then the apparent weight in this case is given by the indication of the spring balance, which is given by 7 newtons. Okay, so now number 2, calculate the value F of the Archimedes upthrust exerted by water on S, knowing that we have the value of the real weight and we have the value of the apparent weight. This value of the apparent weight corresponds when the solid S is immersed in water. So in this case, the value of F, which is given by the real weight minus apparent weight. Now, because this apparent weight is due to water, so the value of F in this case of the Archimedes upthrust will be corresponding for the case when S is immersed in water, which is given by, so the value of the real weight is given by 8 minus 7, which is equal to 1. Now because the real weight and the apparent weight are in newtons, so the value of F will be in newtons. So F is equal to 1 in newtons. So what does this value represent? It is the value of the Archimedes upthrust force F exerted by which liquid? By water on the solid S, because this apparent weight is due to water. Now in number 3, deduce the volume V of S. Now, and by deduce it means that we need to use the part just previously before. In part 2 we have determined the value of F, and we are interested in determining the volume. So F and the volume are related via the following formula, that F is equal to the density of the liquid, which is in this case the density of water, multiplied by the immersed volume of the solid S multiplied by the value of G. So knowing that this is the immersed volume, and the volume that we are interested in calculating is the volume V of S, so actually Vi is equal to V, because here, as they mentioned, that S, which is very important, S is completely immersed in water. Then let's say, since S is completely immersed in the liquid, then in this case we have that the volume of the immersed part is equal to the volume of the solid S, which is denoted by V. Now, rewriting this formula property and replacing Vi by V, we have that F is equal to rho multiplied by V multiplied by G, knowing that we are interested in determining the value of V. Constructing the triangle of this formula. So here, because we have multiply, then F will be at the top, rho, V and G are at the bottom. We are interested in determining the value of V. So putting our hand over V, so V in this case is given by the value of F divided by rho multiplied by G. Now the value of F is given by 1, and the value of rho is given by 1000, and the value of G is given by 10. Plugging this fraction on the calculator, then the value of V will be given by 1 times 10 to the power minus 4. Since everything in the SI, so the value of V will be in the SI, which is meter cube. So here we have determined the volume of the solid S, which is given by 1 times 10 to the power minus 4 meter cube. So V is equal to 1 multiplied by 10 to the power minus 4 meter cube in the SI. Let me make some space for the third part of this exercise. Now part 3. Now S is completely immersed in alcohol, figure 2. They mentioned figure 2, then now we can use it. The spring balance indicate in this case 7.2 newtons. So what does this indication represent? It represents the apparent weight when the solid S is immersed in alcohol. So this apparent weight is different than this apparent weight, because this, it corresponds when the solid S was immersed in water, while this corresponds when the solid S was immersed in alcohol. So let's refer to number 1 first. Calculate the value F prime of Archimedes upthrust exerted by the alcohol on S. So knowing that the real weight will not change, which is given by 80 newtons in this case. However, the value of the apparent weight changed, and it's given by 7.2 newtons. So the value of the apparent weight, here let's denote it by W apparent prime, which is given by 7.2 newtons. Knowing the value of the real weight and the apparent weight prime corresponding for alcohol, F prime then be calculated using the following formula: the real weight minus W prime apparent, which is equal to 8 minus 7.2. Then F prime will be given by 0.8, since both the real weight and the apparent weight prime are in newtons, so F prime will be expressed in newtons as well. Then the value of F prime is equal to 0.8 in newtons. Now in number 2, deduce the value rho prime of the density of this alcohol. Deduce, it means that we need to use the part just previously before. We know that the values of f prime and rho prime are related via the following formula, that f prime is equal to rho prime multiplied by vi multiplied by g. Knowing that we are interested in calculating the value of rho prime, so constructing the triangle of this formula, here what does rho prime represent? It represents the density of this liquid of figure 2, which is alcohol. Now here, because we have multiply, then f prime will be at the top, rho prime, vi and g at the bottom. We are interested in calculating the value of rho prime. Then rho prime will be given by f prime divided by vi multiplied by g. Now the value of f prime is given by 0.8, the value of g is given by 10, and still we need to determine the value of vi. So what does vi represent? Vi represents the volume of the immersed part of the solid S. Knowing that S is completely immersed in alcohol, so the immersed volume will be equal to the volume of the solid. So here let's say between brackets, since S is completely immersed in the liquid, and the liquid in this case represent the alcohol, then vi is equal to v. So usually they give half a mark for this statement, which is important. Now let's rewrite the formula by replacing vi by v. So rho prime is equal to f prime divided by v multiplied by g. Now the value of f prime is given by 0.8, whereas the value of v that we have already determined in number 2, and it will not change because this is a property of the solid. This is given by 1 multiplied by 10 to the power minus 4. And the value of g is given by 10. Now plugging this fraction on the calculator, so the density rho is given by 800. Since f prime, v and g are in the SI, so the value of rho prime will be in the SI, which is kilogram per meter cube. So the value of rho prime, the density of alcohol, is given by 800 kilogram per meter cube. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.